basics of sine and cosine ratio. So let's get started. First, sine stands for opposite over hypotenuse, and we're talking about the opposite side over the hypotenuse in a right triangle. I'm going to go ahead and mark these as right triangles. And there we go. Cosine is the adjacent over the hypotenuse. I'm going to go ahead and spell it out. One thing that does happen too is the way these are pronounced. And for sine, even though it's S-I-N-E, it's still always said sine. Cosine is always said cosine. You can abbreviate both of them with just the 3 letters. Cosine can be C-O-S and sine can be S-I-N. So cosine is adjacent over hypotenuse. So let's take a kind of a look at just 2 examples. Your sides can be identified with either lengths or a variable. And so let's take this yellow triangle. If I wanted to find the sine, the most important thing is I've got to have an angle identified. So I've got an x for this angle in the upper left-hand corner, and then down here I'll call this one a y. So the sine of x is going to be the opposite side to the angle we're talking about. This is the reference angle, x. So the side length is 5, and the hypotenuse is, in this case, is z. All right? That's going to be a different ratio than I would get if I asked for the sine of y. So any right triangle is going to have a different sine for a different angle. Let's take a look over here at the green triangle. I need to have an angle identified here. I'm going to go with this one up here in the upper left-hand corner. So the sine of x is the opposite. That's going to be 11. The opposite side is the one that does not touch. And the hypotenuse, of course, is always the side that is the opposite of the right angle. So if this is the right angle, I kind of shoot straight over here, I see my opposite side, which is 12. Now I can do the cosine for both. The cosine for x is the adjacent side. That's the side that's actually touching, but it's not the hypotenuse. So in this case, that's 7 over z, the hypotenuse. And my cosine over here of x is the adjacent side, which is 5 over 12. Remember SOHCAHTOA, I'm sure you've heard that one, for keeping track of sine and cosine. It stands for, SOH stands for sine equals opposite over adjacent, hypotenuse. And cosine, that's where we get the CAHTOA, or the ka. And the way I pronounce it is so-ka, trying to emphasize the A sound, toa. So so-ka-toa. Cosine is, we got our A for adjacent and H for hypotenuse. And then a tangent, T for tangent, equals O for opposite and A for adjacent. There's another video about tangents. So let's do some problems. Write the ratios for the sine of P and the cosine of P. So I'll just kind of go through these really quickly. This is angle P right here. So looking at angle P, my sine is the opposite side, and the opposite side of this is 4 times the square root of 10 over the hypotenuse, which is 14. You do have to simplify when you have common factors. And since 4 and 14 both have the common factor of 2, I would have to simplify that to 2 times the square root of 10 over 7. All right, and then the cosine for P, for this one, is going to be the adjacent side. Okay, I'm talking about angle P here. So the adjacent side is the one that's touching it. That's going to be the side with a length of 6 over 14. And again, we'd have to simplify that too and turn that into 3 over 7. Alrighty? angle number 2, or triangle number 2, my sine of P is, this is my P right up here. So I'm looking for the opposite side for sine, which is opposite over hypotenuse, so 4 over 5. And my cosine, I use green for that one, cosine of P is my adjacent side. So if this is P, it's going to have to be the side with a length of 3. Remember, it's not the hypotenuse, it's the side that's touching it that's adjacent, but not the hypotenuse. So 3 over the hypotenuse, which is 5. Alrighty. Down here for number 3, my sine of P, and this is my P right here, it's going to be the opposite, which is 4 times the square root of 11 over my hypotenuse, 24. And again, we're going to have to do some simplifying because both 4 and 24 have a common factor of 2. So we'll make that 2 times the square root of 11 over 12. Oh, oops, sorry, I could have factored that better than that. What was I thinking? Let me fix this here. There we go. I can divide them both by 4. So I'm going to have the square root of 11 over 6. Alright, and then my cosine of P is my adjacent side, because this is P. And the side that's adjacent to it is the side marked 20 over the hypotenuse, which is 24. And again, I can simplify that because 4 goes into both of those, and that will turn this into 5 over 6. For number 4, my sine of P, this is P up here, is opposite, which is 15, over my hypotenuse, 17. And cosine, okay, the adjacent side, which is 8, over 17. Alrighty. Now we're going to move on to finding some values, of missing values. The very first problem, I'm being asked to find x, and x is an angle measure. So it says let's round the lengths of the segments to the nearest tenth, and angle measures to the nearest degree. So let's take a look at this. I'm going to be using the cosine because if I look at this, and I'm talking about this angle right here marked x, I've got an adjacent side and a hypotenuse. So I know that the cosine of x equals 8 over 18. And what I need to do is use a special feature in the calculator, which is called the inverse of the cosine. And on your graphing calculator buttons, it's the one where it looks like it's a -1 exponent. So the cosine -1 stands for the value of the measure of the angle given a certain trig ratio. In this particular case, it's 8 over 18. I could simplify that to 4 over 9. I really don't have to because I'm going to enter it in the calculator, but I'll just go ahead and do it just for fun. So what this says is, if you type this into your calculator, you're going to get the angle that has 4 over 9 as its cosine. Okay? So if I type that into my calculator, I got 63.621, but it says to round angle measures to the nearest degree. I'm going to go ahead and just round that to 64 degrees. I don't make sure I put up my little degree sign. Again, type this in your calculator and you should get 64. Always make sure you're in degree mode, and that's the mode button on your calculator. It's kind of near the top, and when you push mode, you want to make sure you're not in radian mode, that you're in degree mode. Okay, over here we're going to find a hypotenuse right here. I'm going to find this x, and so looking at that, I can see that I've got an opposite side and a hypotenuse. That's going to be my sine. Okay, so sine of 65 degrees is equal to 10 over x. Now what I can do is I can go ahead and multiply both sides by x, and I'm going to get, you can kind of see that over here. So multiply the left side by x and the right side by x, so the x over 1. These two cancel out, and I'm going to have x times the sine of 65 will equal 10. And now I can go ahead and divide both sides by the sine of 65 because I want to isolate x. And that will get rid of the sine of 65 on the left-hand side. Okay. I can just kind of cross through these two. I've got x equals 10 divided by the sine of 65. Just got to type that in the calculator. And when you do, you'll get the length is 11.03. I'm supposed to round to the nearest tenth, so that's going to be 11.0. Since I'm supposed to round to the nearest tenth, even though my tenth decimal place is a 0, I've got to put it in. Okay, number 7, I am looking for this little side right here. So I can see that from this angle, which is marked as a measure of 28, x is an opposite side. And then I also have a hypotenuse. So I'm going to be using my sine. So the sine of 28 degrees equals x over 15. And I want to go ahead and isolate x. I'm going to multiply both sides by 15. And I've got 15 times the sine of 28 equals x. Let me just cross off these two 15s here. So just type that in the calculator. 15 times the sine of 28, and you should get 7.04. Let me just check. I'm supposed to round this to the nearest degree, or the length to the nearest tenth. So I'm going to round this to 7.0. And it is, doesn't say. Yeah. And this video is all done. Thanks for watching.